Selves, the bicycle brake pad problem. Here we go. All right, so here's the deal. So you've got a bicycle tire. The problem tells you that it is 72 centimeters across. Why do people say the word across with a T at the end? One of the great mysteries of life. All right, so our radius is going to be 0.36 meters, yes? Half of 72 centimeters. All right, so here's the deal. When you use the brakes on your bicycle, the brake pads do not do this. If they did, then the distance for the force would be the same as the radius, right? But the brake pads they touch the metal part, right, which is in a little bit, right? Okay, and so the problem tells you that the brake pads, so there's a brake pad, it tells you that they are located 2 centimeters, 0.02 meters from the outside edge. And so if, hypothetically speaking, the bicycle tire is spinning this way, everybody point for me. Which way will friction go? That way, right? Against the motion. So here is my force of friction, which is, I believe, what we're trying to calculate, isn't it? I hope. So I need to find my distance. So my distance is the distance from my pivot point, or my axis of rotation, to where the force is applied. And so my D is not 0.36 meters, it's... What? No, it's not 0.7. You subtracted from the diameter instead of the radius. So it's 0.34. Do you see what I mean, right?
Yeah.
You're not the first person who's made that mistake. All right. So, Lauren, does that make sense to you?
Yeah.
Everybody, does that make sense? All righty. So let's finish this up then, because that's kind of the hard part. So the problem gives us the rotational inertia of the tire, doesn't it? I think it's 0.8 kilogram meters squared. Yes? We'll go with that. Let's see, what else does it tell us? The front wheel is initially spinning at 2 revolutions per second, which really, I guess it should be rotations per second, right? As somebody was kind enough to point out last hour. So 1 revolution is the same as 2 pi radians. So that's 12.56 radians per second. Since we are trying to stop the bicycle, that means that our final angular velocity got to be 0. And we want this to all occur in a time of 3 seconds. So we can find our alpha. And we will at what are you guys giggling about? 4.19 radians per second squared, yes? Everybody good? All right, so now, well, okay, so let me say this. Can I use a jumper to find the acceleration and then do F equals ma? No. Please, 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 when you're talking about rotation, don't use F equals ma. Because the whole bicycle tire is not accelerating linearly. Okay? And every point on the wheel has a different acceleration, right? It's the angular acceleration we care about. All right? So, I think we can now do net torque equals I alpha. I know my I because the problem gave it to me. I know my alpha because I just found it. Multiply those, and your your net torque, rather, will give you 3.35 newton meters. And so now I can find my force, because I know that net torque is FD. I just found my torque, 3.35 newton meters. I do not know the force, but I do know the distance is 0.34 meters. So divide it, and you get pretty close to 10 newtons. We're going to call it 9.86 newtons. Cool? All right. Any problems with A? All right, and then B, Brady, to your point, you could absolutely do 1/2 alpha t squared. Did you try it and it didn't work?
Yeah, I must have done something wrong.
Yeah, well, I did that too.
Oh, you did it?
Yeah.
Maybe you did.
Wait, it worked.
I also did that and I didn't get it.
Yeah.
Curiouser and curiouser. Well then somebody, did you guys get something close?
Oh, a little bit.
All right, well let's do it then. Let's see if we can figure out what's going on here. So let's see. So here's all my given information here, so let's do this. Oh, that's not what I wanted to happen. There we go. Okay, so let's see. You guys are looking at this guy. Delta theta is 1/2 alpha t squared plus omega I times... I know why it didn't work. Ha ha. All right, I'm going to write down what you guys did, and then we'll see if we can figure out what the problem was. Delta theta is 1/2. Alpha is 4.19 radians per second squared. The time is 3 seconds. Don't forget to square it. Our initial angular velocity is 12.56 radians per second for 3 seconds. And plug it in, and you get a really big number. What?
Yeah, I think I did get this number. Acceleration is negative.
Yeah. I haven't been keeping track of the signs here because they're somewhat arbitrary, but here it actually does matter. That you need to either make your initial velocity or your acceleration negative, because the acceleration is working against the velocity, right? So if you make this guy negative, then everybody should be good. Cool. I'm glad you asked about that. That did not occur to me that that would be an issue. Cool, you guys? Is that your problem, Noah?
Yeah.
Joey? Awesome, horrific. Love it when we're able to solve issues. Questions? Yes?
Did you go over number 12?
I would love to go over number 12. Are there any questions on whatever number this was before we go on?